Okay, last night I had a great large pizza. It was delicious. And I ended up eating. It was cut into a whole lot of slices, but I ate 29.58 of the pizza. That's how much I ate. 29.58. Yeah, it was good. Can you visualize how much of that pizza I ate if I said, hey, I ate 29.58? No, it's sort of hard, isn't it? Okay, well, let me reword that. Last night I had a big, large pizza. It was delicious, and I ate half of it. Is that easier to understand? Yeah, because there's Mr. Pizza. It doesn't matter. Boom, you ate half. 29.58 is the same as a half. What do we prefer? We prefer the smaller fraction. We prefer to simplify fractions because it makes it easier to understand, to comprehend. And we like everyone to also, if everybody simplifies their answers with fractions and other things, we all get the same answer. So just like we like to simplify fractions, we like to simplify expressions with variables also. So let's say we have this, and let's say you have to plug in the number, let's say 7. 7 squared plus 8 times 7 plus 12, all divided by 7 plus 6. Well, we could do it, but what if we could simplify this guy? Now, as soon as I see that top, it's a trinomial. I'm like, hey, I wonder if that guy factors. Well, let's think. The back number would give us an idea. We look at what multiplied together to give us 12. 1 and 12, 2 times 6, 3 times 4. And we need to create a what? 8. Well, that means it was a 2 and a 6. So that top, and we have enough experience now to realize, hey, that's an x plus 2 times an x plus 6 all over an x plus 6. Well, something looks a little familiar here. Well, wait a second. Whatever I plug in for x, let's say it's a 3. If you plug in a 3 here and a 3 there, you'll get 9 and 9. And what is 9 divided by 9? 1. They would cross out and become little ones, wouldn't they? And if I plug in a 7, I get 13 and 13, they'd cross out. So what we realize is, hey, this simplifies down to really just an x plus 2. Now you tell me, would you rather plug 7 in up here and square it and multiply by 8 and add 12 and then divide by 13? Or just plug in here and go, 7 plus 2 is 9. You would much rather plug in here, wouldn't you? Yeah. No matter what you plug in for x up here, it's the same as just taking the x and adding 2 to it. See how much simpler that is? That's why we call it simplifying. Now, we have to be careful because we always got to sort of look at this bottom and realize, hey, you can't divide by 0. That's against the law, against the rules, because division is saying what you're putting it in groups of, and you can't put things in groups of 0. For example, if I have 6 divided by 2, I have 6 items, put in groups of 2. Hey, you got 3 groups. I got 6 people again. 1, 2, 3, 4, 5, 6. Put them in groups of nothing. What? Exactly. You can't do it. That's why we don't divide by 0. So we do need to make a statement here. We realize that when this x plus 6 crossed out, you could no longer see it. Now, originally, if you tried to plug negative 6 in, people would realize, oh, you got a mistake. But down here, if I plug negative 6 in, it looks like I get an answer of negative 4. I have to warn people that you can't use negative 6. So what we do is we say, hey, you can't let x equal a negative 6. We have to put a restriction there. Whatever you cross out, in this case, it was x plus 6. You have to say, hey, you have to realize that x plus 6 can't come out to be 0. We can't let that 0 happen in that denominator. So when we subtract 6, we can see we don't get 6. And I know that's a little difficult for us, but we'll work on it. Let's look at the next one. Wow, we have a trinomial divided by a trinomial. I'd really hate to plug a 7 in there now, or a 9 or an 11 or 14, or what if I had to plug a 23? Wow, that'd be awful, even though I like 23 because it's prime. So if we factor the top, and we're just going to go ahead, I'm going to skip to it. It's an x plus 2 times an x plus 5. I can see it because I know 2 times 5 is 10, and 2 and 5 added gives me my 7. In the bottom, what's going to multiply together to give me 6, yet add to be a 5, and x plus 2 times an x plus 3. Do you see anybody that's the same? Yes, this guy and this guy are going to cross out. So this simplifies to an x plus 5 over an x plus 3. It's going to be a lot easier to plug into this than it is that, isn't it? Yes. So this is simplified. Now, we do need to make that statement of what x can't be. because we crossed out this x plus 2. So when we crossed it out, it disappeared and they can't see it down here. But technically it's there. So we have to make sure we say, hey, we can't let that x plus 2 come out to be a 0. Because if you did, 0 times whatever is going to create a 0 in the bottom, and that's going to create a big problem. You can't do it. So if we subtract 2, we realize x can't be a negative 2. We do need to make that statement, okay? And we're going to work on that in class. So there you have simplifying these polynomials when they are fractions.